Welcome back to our project. Till now we have removed the duplicates from the dataset. Now we will check for the outliers. Do you know what is outliers? Outlier means those data which are extreme. Suppose if I write df dot head, it will show us the first 5 rows. Okay. Now let's say that average people work in the company for 2 to 7 years. Okay. Maybe maximum 4 to 5 years. But what happens if there is someone who is working for 15 years or someone who has left within 1 month or 2 months? Then these data are extreme. These are not average. These are exceptional. These are kind of far from the average. So we can call this data as outliers. So now our target is to see how many outliers are present in our data set. Okay. Now how can we do that? So we have to write plot dot figure fig size equals to 6 comma 6. Now see here it is showing as underline because I told you that when I will do the project I will import the libraries. Write matplotlib inline that is required for visualization and import matplotlib dot pyplot as plt and import cborn as SNS. Okay, these two are visualization library. That means we can create different kind of graphs using those libraries. Okay. Now this one means that I want a figure that will have a 6 size. Okay. Now write plot dot title. Title means I'll give a name to the figure like detecting outliers. Fine. Uh, if you want, you can give font size equal to 12. Fine. Now do the box plot. SNS dot box plot x equals to df. What is the column here? The column name. The column name is number. No, sorry. The column name is time spent company. Fine. Now let me run this one. Box plot, not PLT. Okay. See, we can see these are the outliers. So now let's check how many outliers are present in our data. Okay. Now we will write like percentile 25 equals to df time spent company dot quantile 0.25. Fine. So it will give us the 25th percentile. I hope you know percentile. That is a part of the statistics. You have to know, otherwise it is not possible for you to understand. It's like you are dividing the data into 4 parts. Starting from 0, 25th percentile, 50th percentile, 75th percentile, then 100th percentile. Okay. So it is just dividing the data set into 4 parts. Okay. But you have to know this. If you don't know, then you can let me know in comment section. I'll make a video for that. Now I want the uh, difference like equal to percentile 75 minus percentile 25. Okay, so it will give me the difference. Now I want, now how can I distinguish the outlier? I will make an upper limit for my dataset and a lower limit for my dataset. So whichever data are above the upper limit or below the lower limit are known as outliers. Okay. Now suppose I write upper limit equals to percentile plus 1.5 into IQR. That means the difference will be multiplied with IQR and that will be added with, this one means it will be added with 75th percentile. So if you add the 75th percentile with this, then you will get the upper limit. So that is the maximum you are considering. Any data above that upper limit is considered as an outlier. Next one is lower limit. Lower limit equal to percentile 25 minus 1.5 into IQR. Same, you are just getting the lower limit. That will be below percentile 22. Up to this limit, you are considering the data. Now let's print them. Print upper limit print lower limit. Fine. So you can understand the average. How did that happen? Oh, I'm so sorry. Here you have to give the 75th percentile. I want the 75th percentile. I wrote it 0.25. Now let's check it. Now you can see that upper limit is 5.5. That means maximum people are staying for 5.5 years and minimum they are living in 1.5. If there is anything extreme, like someone has left within 1 year or someone has worked for more than 6 years, so these are known as outliers. Okay. Now let's see how many outliers are present in our data set. Now for this I will write DF time spent company greater than upper limit. Those who are greater than upper limit are outliers, and as I said, those same time spent company less than lower limit are also outliers. You get my point? This is in a bracket. This is for lower limit and keep them in DF. Fine. See, these are the outliers. Let's check. Time spent. They have retained for 6 years. They are for 10 years. Oh, there are so many outliers. Okay. Now keep them in an outliers. Fine. Now let's check the count. So it will give us the number. See, there are 824 outliers. Okay, 824 people are kind of exceptional. Okay, fine. Now let's check other columns. See, what are the other columns? Average monthly hours, number of project. Now let's see that what is the relationship of average monthly hours, number of project with how many have left or how many have resigned. Okay, for that first I can create a box plot. So SNS dot box plot. Now you have learned data equals to DF, x equals to uh, average monthly hours. So it will be average monthly hours, y equals to number project equals to number project, and q equals to left. Fine. Okay, give it a horizontal orient. Orient equals to h. Now see, the box plot is created. 0, this means they have not left, they have left. Here you can see those who have worked for 250 to 300 hours, all left. Worked for 7 projects, all left. Here also people have left who have worked for more hours. They have stayed. Here maximum people have stayed. The average works 150 to 250. Average project, number of project 5. Here number of project 4. This is also a good symbol. Here also people have stayed but people have left also. So 4, 5, 6, I can not 6, 4, 5. So 4, 5 kind of optimum. 3 is also okay. But in 2 projects, who have worked in 2 projects also have left. But who have worked in 7, maximum left. Who have worked for more number of hours, maximum left. Here also left. Here also more number of works kind of left. Okay. So this is the average hour an employee should work for staying in the company. 150 to 250 and kind of 4 to 5 projects. Okay. Let's check one more histogram. SNS dot hist plot data equals to df x equals to number number project, number project. Now let's see. Okay, so you can see 2, 3, 4, 5, 6, 7. Uh, it is showing us the number of project. Now we have to check how many have left and how many have retained. So u equals to left. So there it will create a u for this also. See here left 0. That means not left. This one left. But these are overlapping. Okay, make them distinct by giving multiple equals to dodge. Now see, it will create a distinct. Okay, fine. It is looking fine now. See, those who have worked in 2 projects left. 2 projects are unable to satisfy an employee. 3 projects, they are highly satisfied. Very rare left. 4 projects, highly satisfied. 5 project is also good. So we can say 3, 4, 5 are fine. But 6, this is also not so good, and 7 means everyone has left. Okay. So nobody will work in 7 projects. But 3 to 5 are good. So from here also we have kind of derived the same. And here also we have got a good point. So how many number of works and how many projects an employee should do so that the employee stays in the company. Fine. Now we can check how many people have worked in 7 projects and have left the company. We can check that. Okay. First, let me write df number project equals to 7. Then we will get that how many people have worked in 7 projects. So it is giving me the boolean value for all the rows. Okay, first show me the output. So df 7. Okay, this is showing me the data set. Now I want them who have left. Only those who are left is 1. So this many. Okay. But I want the number of count. So I can write value counts. So it will give me the count. See, 145. So 145 people have left. Okay. They have worked in 7 projects. 155 people have worked in 7 projects, have left. So write the steps we have done for the day. We have done all these things like deleted the duplicated values. Then we have checked outliers. Next we have created visualized the relationship between monthly works with number of project. Okay, what is our conclusion right now? That the optimal number of project is between 3 to 5. Second, those who have worked more than 250 hours, that was 250 hours, right? Have left. Third, those who have worked in 7 projects have all left. Okay, so these are the things we have got till now. Okay, we will do more analysis and visualization in our next class. Till then, bye. Happy learning.